Okay, this is the Wheatstone Bridge experiment. And what it's about is determining an unknown resistance with other known resistances. So let's say you have this circuit here, these four resistors connected this way. That one right there is the unknown. That's Rx, okay? And then you have R1, R2, and R3, all right? So Rx is the unknown, R1, R2, and R3 are knowns. Let's say furthermore that not only R1, R2, and R3 are known, but you can make them anything you want. You can vary the values and select any value you want to. Okay, now Rx, you're stuck with it, but you don't know what it is. We're trying to figure out what it is. We can vary R1, R2, and R3. Here's what we're going to do. Let me add something to this diagram really quickly. Okay, let's say I just added this ammeter in between there in that gap. Okay, so let's say we're trying to measure that current. We're going to call it IG. Okay. So IG is that current right across that middle strip right there. All right. We're going to measure that current. Now, ordinarily, if you were to connect four resistors together this way and just four random values, there would almost certainly be some current there. It would be pretty amazing if there weren't. So let's say there's a current there. But we said these resistors are adjustable. The known ones are anyway. Let's say we adjust R1, R2, and R3 so that we get zero current across that gap in the middle, okay? So in other words, we're going to play around with R1, R2, and R3 until we get zero current in the middle, all right? So when we've achieved that, the only way that can happen is if the resistors are proportional in this way, okay? If Rx over R3 is equal to R1 over R2. So if there's zero current across the middle, that means that you have basically chosen resistors so that they are proportional in this way, all right? And since you know what R1, R2, and R3 are, you just plug in and you can get Rx, okay? So that's the deal on that. So that's what we're going for here. Okay, so let me show you some of the equipment we're going to use. The R1 and R2 that can be varied are actually one device. They're combined in this one big long device here. This is the slide wire bridge, and I don't know how well you can see this, but there's a real thin wire on it, and there's a meter stick, okay? And so you can slide this contact different places, and you can select, whatever position on the wire that you need. And basically this wire on top of the meter stick, it will serve as both R1 and R2. Depending on wherever you have the contact set, one section of it will be R1 and the other section of it will be R2. Okay, so it turns out, that's why you might see written on the board, it might be up there, I'm not sure, but that formula Rx over R3 equals R1 over R2, we could also just as well use L1 over L2 in place of R1 over R2. We don't really care about the resistance of these. We just need the length will work for us. Okay, so the current meter that we use to measure that IG current across the gap, across the middle of the circuit, that is where we use this thing, the galvanometer. So it's basically just an ammeter, but it's specially designed to measure really small currents. And it's got three buttons here, or I think the manual calls them keys. And so you aren't really going to have to make numerical measurements. It's a matter of just looking for when current is zero. The first one, the first key, it measures to a coarse degree, and then the next key measures to a finer precision, and then the last one, number 3, measures to the finest precision. So you just kind of work your way through while you're varying the position of the slide wire, okay? And then in The first part of the experiment, R3, is going to be this guy here, just this 1 ohm resistor. All right, so it won't actually be varied in the first part of the experiment. The later part of the experiment, you're going to use for R3, you'll use this. This is the decade resistance box. So it's pretty straightforward. You just turn the knobs and you can select whatever value of resistance you need at the time. Okay, so that's all there is to that. All right, so also in the first part of the experiment, your unknown is going to be one of these spools of wire, or some of you have one that looks a little different than this, like you used in Ohm's law experiment. We're going to treat this as an unknown. And the second part of the experiment, the data sheet 3, data sheet 2, you'll go back to using a circuit board like we had last time, and you'll create different combinations of resistors with it, and you'll treat that as the unknown. All right. So basically, this is all about trying to find an unknown resistance, which it may seem a little silly because you might figure, well, why not just use the ohm meter? And you could. But ohm meters don't just grow out of trees ready to use. Somebody has to design them, and so this is one possible design that could be incorporated into an ohm meter. So this is one reason why we study it. It's a little old school, but anyway, it's a good exercise. All right.